Hello, everyone. So, today what we're going to do is we're going to talk about lesson 10.4, comparing two populations. The learning target for this is I can use the measures of center and measures of variation to compare two samples and make comparative inferences about those two populations. Whew! Yeah, the 10.3 one that we just did on Friday, this one's going to be a booger too. All right, so here we go. First thing we need to do is we need to really talk about what is distribution. Well, distribution is basically the shape of the graph. In other words, the overall arrangement of the data, how the data looks. In our particular case, we're going to talk about two different types of distributions. We're going to talk about the symmetric distribution and we're going to talk about the asymmetric distribution. Starting with the symmetric distribution. The symmetric distribution is when the data is approximately the same shape to the left of the center as it is to the right of center. So I've got a couple of examples here, and we have this one, we have a box plot and we have a dot plot. Notice here on the box plot, if I were to take this and fold it and write down the center and match it up, it would match up exactly. And the same thing for this dot plot. If I were to fold it down the center and match it up, it would match exactly. Now, for asymmetric distributions, it does not match up exactly. The shape of the data on one side of the center is very different than the shape on the other side of the center. So here is a dot plot. Obviously, if I were to fold it down the center and match it up, I couldn't match it up. It would not match up exactly. In fact, it wouldn't match up hardly very well at all. And same thing for the dot plot. Fold it down the center. It's quite a bit different. In fact, actually on the left-hand side, you see how much longer the left-hand side is from the right-hand side. The data values on the left-hand side are much more spread out than the data values on the right-hand side. Okay? Now, based on that kind of the shape of the data helps us to determine what number we need to use to best describe the center of the data, the middle of the road. Okay, if we have symmetric data, to be honest with you, we can use both median and mean. If we have asymmetric data, though, we can only use the median. The reason why is because these numbers down here are going to significantly impact the average with these numbers. If I were to find the average, the mean of this data, of this dot plot, I would find the mean more so down here. And as you can see, that doesn't really describe the data overall because more than half of the data would fall to the right and less than half of the data would fall to the left. So we need to find something that would represent the middle of the road. So 50% is on the right, 50% is on the left. All right, so here we go. Choosing the best measure of center and variation based on the distribution of single box plots. Now let me kind of talk a little bit. As I mentioned, measures of center, we use the mean, median, and the mode. Very rarely do we use the mode. We're really only going to be talking about whether we need to use the mean or the median. And we already kind of talked a little bit about how that distribution would affect the mean and the median. On the variation, on the other hand, it kind of depends on what we use for our center. If we use mean to represent the center of our data, then we're going to use the mean absolute deviation to represent the variation. If we use the median, then we're going to use the IQR to represent the variation. Okay? So just think of it this way. Mean absolute deviation, mean and MAD go together, and median and IQR go together. All right, so looking at what we got. If we've got a box plot, in other words, a box and whisker plot, if it's symmetric distribution, we're going to use median or IQR. And we're also going to do the same thing for asymmetric distribution. So no matter what, if you got a box plot, we're going to use the median to represent the center, and we're going to use the IQR. And that makes sense because we've made box plots, and all we use is median when we're making the box plots. However, on the dot plot, we could very easily find the average. We could very easily find the mean. We could very easily find the MAD and the IQR from a dot plot. So if we have symmetric distribution on a dot plot, we can either use mean and MAD or median and IQR. But when we're talking asymmetric, we would have to use the median and IQR. Okay? Whew, that's a lot. Okay, so let's kind of plug it in together. So I'm going to carefully scroll down because I actually have the answers right here. So select the appropriate measure of center and variability based on the shape of each distribution. Write mean and mean absolute deviation or median and interquartile range. If you can use either, write the word either. So take a pause the video, identify what measures we would use, and then come back and check your answer. Okay, so looking at the first one on the race times on the left, we see that the distribution is kind of all over the place. It's not symmetrical at all. If I were to fold this in half, they would not match up. So, and because of the fact that this is a dot plot, it's a dot plot, asymmetric distribution. That means I would use median and IQR. Over here on the right-hand side in temperature one, you would see that if I were to fold this in half, it would match up exactly. So this is a symmetrical distribution. This is also a dot plot. So dot plot, symmetric distribution. I can use the mean and MAD, or I can use the median and IQR. So on that one, I wrote either. Okay? All right. Now let's talk about double box and whisker plots. Double box and whisker plots, or double box and double dot plots, are basically two box plots or two dot plots that use the same number line so that they can be easily compared. So we have information from one population and we have information from another population on the same number line. So here's an example of a double box plot. So as you can see, the first one up above is one population. The second one is another population. And based on that and how the plots are, we can make some inferences. One of the things we can figure out, since this is box and whisker, that means we're using the median, is that the median for the top population is much higher than the median for the lower population. I know that because the middle dot's the median. On the lower population, it's 15. On the upper population, it's 35. I can also see that the IQR for both of them are the same because 40 minus 30 gives me 10. 20 minus 10 gives me 10 as well. So both of them have the same IQR, but you would also notice that the range, overall range, is less in the top population than it is for the bottom population. The range in the top population is only 20. The bottom is 35. Looking over here on the right at the dot plots, as you can see that these are both symmetrical dot plots, but one population is further down, further to the left on the number line than the other population. So as we can see, no, I don't know what they're comparing here, but let's say if they were comparing scores, well, the bottom population would do much better than the top population because the dots are further to the right. All right. Now, having said all that, when we're talking about double box and double dot plots, we also need to decide whether we're going to use, which measures we're going to use, whether we're going to use mean and MAD or if we're going to use median and IQR. And just like the single ones, we have to look at the distribution. So if both sets of the data are symmetric, we're going to use either mean and MAD or median and IQR. Of course, as we talked, if we've got a box plot, we have to use median and IQR. But if we have a dot plot, like this one right here, we could use the mean and the MAD. If neither set of the data is symmetric, no matter if it's a box plot or a dot plot, we're going to use median and IQR. And if only one set of the data is symmetric, same thing. No matter whether you're using a box plot or dot plot, we're going to use median and IQR. Whew. All right, I don't know about you, but I need a brain break from that. So take a minute or so to kind of regroup your brain and rest a little bit, and then go back and start video or watch video 2.